So our speaker tonight is Liz Southard, who has 10 years of archaeological field experience, including 2 years of experience doing cultural resource management. Liz received her bachelor's in anthropology from the University of South Florida in St. Petersburg and her master's in applied anthropology from the University of South Florida, Tampa. She currently works at TerraXplorations Incorporated as a principal investigator and serves as vice president for the Alliance for Weeden Island Archaeological Research and Education, or AWARE. Most of her experience comes from Florida and Georgia projects, where she has worked as a project archaeologist and field director. Her main areas of interest include subsistence practices, seasonality studies, and settlement patterns during the woodland period in the Southeast US. And so we're really happy to have you, Liz. I'll go ahead and stop sharing my screen and you can take it away.
Thank you for the introduction, Jamie. And thank you all for coming this evening. Let me click some buttons. And there we go. And just 1 second, I gotta figure out how to get rid of this. There we go. I think. Okay. So again, thank you all for joining this evening. Today I'm going to be talking about my thesis research. The title of my presentation is Feasting and Fishes, an investigation into seasonal patterns, labor organization, and monumental architecture from Florida's Crystal River site and Roberts Island Shell Mound Complex. Archaeologists have recently shown the construction of the two largest prehistoric earthen mounds in the southeastern United States, Monk's Mound, which is pictured here, at Cahokia, and Mound A at Poverty Point, which is pictured down here, took place in short episodes rather than the formally accepted notion of gradual stages of accumulation over a long period of time. In order to accomplish these feats, mound builders would have required the ability to organize and coordinate a large labor force. There. Archaeologists have also engaged in an extensive conversation regarding the construction pace and intentionality of monumental shell mounds that are found on coastlines throughout the world. This argument centers on whether these accumulations of shell built up over a long period of time or are planned and rapidly constructed. Notably, aspects of both of these discussions draw from either acceptance or disagreement regarding the simplicity of the economic, social, political, and ritual organization that is traditionally associated with most hunter-gatherer societies. Pictured here are three accumulations of shell. The picture on the left is from the famous Weeden Island site here in St. Petersburg, Florida. The picture on the upper right is from Sapelo Island, Georgia. And finally, the picture in the bottom right is of a shell accumulation from downtown St. Petersburg. Some may say it is easy to differentiate which of these should be considered an intentional monumental construction, the one from St. Petersburg, right? However, some have argued that archaic period shell mounds and monumental constructions are as well. Thus, archaeologists need reliable methods to provide multiple lines of evidence to support their interpretations of these features. As you can see here, the midden, at least in my opinion, looks rather similar to the shell ring. So that is one of the reasons that we need different methods to be able to interpret and understand why these or how the differences between these types of features found on landscapes. While the intentionality of mounds can be apparent at some sites, as can be observed from Mound A at Crystal River, detecting archaeological signatures for short, episodic constructions and organizational elements of the labor force used to facilitate such constructions can be elusive. Season of capture studies, which estimate the season of the year an animal was killed, are offering new lines of evidence that are aiding in the ability to identify intentionality of monumental shell mound construction and possible indications of seasonal aggregations of laborers, especially when complemented by well-dated stratigraphic construction sequences. Several of these studies have used invertebrate remains to determine seasonal information. Unfortunately, these studies are generally limited to small sample sizes, likely because it is costly to conduct stable isotope analysis. Fish remains offer archaeologists with a vertebrate faunal class that can be utilized as a source for pre-contact seasonal information. Otoliths, commonly known as earstones, are small calcium carbonate structures located directly behind a fish's brain. Like tree rings, they record daily environmental information in incremental growth bands. These growth bands produce an opaque zone during periods of slower growth and a hyaline or translucent zone during periods of faster growth. These zone types can be linked to seasons, with the opaque slow growth zone commonly associated with winter and cooler periods, while the translucent fast growth zone is frequently associated with summer and warmer periods. My research examined the temporal patterns of monumental shell mound construction at two woodland period sites, the Crystal River site and the Roberts Island shell mound complex. These sites are located on Florida's west central Gulf Coast. As you can see indicated on the map, here is the little dot indicating their location on Florida's Gulf Coast. To investigate the temporal patterns, I developed the following research question. Were the residents of Crystal River and Roberts Island and possibly participants from afar engaging in seasonal deposition events involving the construction of monumental architecture at these sites? The primary hypothesis I tested to address this question is that seasonal deposition patterns differ between midden and mound contexts because the mound material was deposited in episodic events at specific times of the year. I developed this hypothesis from Dr. Thomas Placon and colleagues' research, including one study that suggests rapid episodic deposition of oyster in the site's mounds that is supported by well-dated stratigraphic evidence, and another study that reveals oysters were harvested in mound contexts almost exclusively during the winter months. To test this hypothesis, I conducted season of capture analysis on red drum and spotted sea trout otoliths recovered during excavations at Crystal River and Roberts Island. The approach I used is known as marginal increment analysis, which measures the outermost hyaline or opaque growth ring in a cross-sectioned otolith. This measurement is compared with modern otolith marginal edge widths with known seasonal correlates to determine the time of year a given fish was caught. Florida Fish and Wildlife's Research Institute granted me access to their otolith database, which consisted of thousands of data points of species-specific marginal edge widths to develop and use as comparative sets. As access to this information allowed me to develop marginal edge width histograms for Florida's Gulf Coast, which most of us know do not conform to conventional winter, spring, summer, and fall seasons. I then used these to determine seasonal information for my study, and hopefully will be used for future studies as well. And this is another image that kind of gives a little bit more detail. So when I'm discussing the marginal edge, it's going to be the outermost growth band. You can see right here, this is the 6th annulus, and the measurement includes from this dark growth zone to the edge. And then these growth bands here in the center, I actually use those to compare with the modern assemblage to ensure that the growth rate between the modern and the archaeological assemblages are similar, so that the estimations and determinations for seasonality that I am making, the two different data sets are comparable. While determining what season of the year these monumental feats were being accomplished, I wanted to take my research a step further. So I attempted to address a secondary research question. Specifically, I sought information on what mechanisms drove the people to participate in village construction projects and continually engage in seasonal aggregation events at Crystal River and Roberts Island. Numerous archaeological investigations from around the world suggest that the construction of monumental architecture is linked to ritual behavior. Notably, archaeologists have linked the ritual behavior of feasting with organizing labor for monumental constructions. James Knight has extended this perspective to implicate feasting in the emergence of platform mounds in the southeastern United States during the Middle Woodland period, thus begging the question to be asked, was feasting occurring at Crystal River and Roberts Island, and did it act as a mechanism to organize a voluntary labor force to construct monumental architecture? If mound construction was occurring in particular seasons, it implies shorter intervals, and by extension, the possibility that mound building was tied to feasting. Oops. That is the same information. 1 second. There are studies that have provided evidence that feasting events were taking place during the woodland period, including at the Garden Patch site, a middle woodland and late woodland civic ceremonial center on Florida's northern peninsular Gulf Coast. Researchers Hyde and Wallace's study from this site provide multiple lines of evidence to support feasting events occurred in cooler months, and primary deposition of this material occurred on one of the platform mounds at the site. This first line of evidence comes from a previous isotope study of oysters from mound contexts that contain signatures for harvesting of oysters during cooler months. A study like this also mirrors the one with findings from Crystal River and Roberts Island. Second, Hyde and Wallace also conducted analysis of faunal material unearthed from one of the mounds, which consists mostly of primary deposits. They argue this is evidence of an abundance of, which they argue is evidenced by the abundance of toadfish and certain identified bird species that are not present in midden context. Many of the avian remains identified from this mound are migratory and only present in the region during the cooler months of the year. The combination of Knight's idea that feasting events played a role in the widespread adoption of mounds in the Southeast and a growing number of studies that indicate feasting events were taking place and evidence is being derived to support the assertion. A question is begging to be asked. Were feasting events occurring at Crystal River and Roberts Island? And did they act as this mechanism to organize the voluntary labor force that would be required to construct monumental architecture? To delve further into this question, I drew upon theoretical perspectives of feasting outlined by Michael Dietler and Ingrid Urbich's collective work events approach. This approach postulates that the use of feasts to mobilize collective labor has been a widespread and fundamental economic practice of societies around the world. In fact, variants of the practice are so strikingly omnipresent in the ethnographic and historical literature that a good case can be made for acknowledging it both as virtually a universal feature among agrarian societies and as nearly the exclusive means of mobilizing large voluntary work projects before the spread of the monetary economy and the capitalist commoditization of labor and creation of a wage labor market. Dietler and Urbich also propose a model of collective work events that is depicted here on the slide. The model serves as a basis for understanding both the conversion functions of feasts and their potential for exploitation. The researchers state they do not view or want these types of collective work events to be seen as opposing binary categories. Instead, they view these work types as a continuum. Thus, the type and/or size of the project determines where on this continuum a work event will fall. Work exchange events rely on reciprocal relationships and are limited in the number of people they are able to mobilize. These events require little exchange of food or drink, but carry the weight of the labor being returned at a later date. On the other end of the spectrum are work feasts, an event in which a group of people are called together to work on a specific project for a day, or more, and in return are treated to food and or drink after the host owns the proceeds of the day's labor. These types of feasts do not have a reciprocal component. The only requirement is that hosts treat the laborers to lavish amounts of food and or beverage. They suggest these events can attract a diverse and very large group of people because it is the scale of the hospitality, the copiousness and quality of the food and drink provided, and the reputation of the host for providing these in abundance. This is what draws people to participate rather than the close social relationships. Further, work feasts were and are used to perform a wide variety of tasks for which the sheer multiplications of hands either allows a project to be done in a short space of time or enables a project that could not be undertaken otherwise. The need for the multiplication of hands is an idea that has been put forward by southeastern archaeologists, including the work during Wallace and Hyde's study from Garden Patch, and also by other researchers. They assert that social ties and alliances were the mechanisms that brought the people together to take on these monumental construction projects during the Middle Woodland period. While I agree, alliances likely played a significant role in daily and ritual activities at these sites, I do wonder and question whether they alone would have been able to gather the number of people needed to construct monuments found at some of these Middle Woodland centers, including Mound A at Kolomoki and Mound A at Crystal River. Thus, I put forward the idea of Dietler and Urbich's work feasts work exchange continuum as a means for a village to attract a large enough group of outside participants to assist with these large-scale projects. Additionally, I too agree with the current lack of evidence for individual political powers of authority that is often noted and associated with the Middle Woodland period. However, Dietler and Urbich do not specifically state that having an individual political leader is a requirement for these collective work events. I envision these communal consumption events as an undertaking of the entire village and possibly even participants from afar, especially since it would have required the effort of many villagers to gather the resources to put on these elaborate events. Well, the groundwork is set for my research questions, I turn attention back to the sites and methods I used to address my research. Very briefly, it is important to note the phase of construction and growth that took place at Crystal River and Roberts Island. Much of my study is based on research Thomas Flacan and Victor Thompson conducted at these sites, as well as a multitude of graduate students. The following slides provide Bayesian modeled dates for these phases. Evidence suggests that Crystal River became an important location during the early woodland period. At this time, the site likely served as a vacant ceremonial center where people would come and bury the dead. Evidence from this phase suggests that engagement with the Hopewellian interaction sphere, and this is based on the exotic artifacts that were recovered from the main burial complex. As time passed, the area became populated with likely what began as seasonal aggregations and then became an emergent village. By the Middle Woodland period, the village and midden area had expanded and numerous monumental constructions were present on the landscape. During this phase, the early stages of Mound A, which is over here, Mound H, which is here, Mound K, which is here, and Mound J appeared on the landscape. And the midden expanded a great deal. All of these features suggest growth was occurring at this location and a permanent village had been established. The additions to the landscape at Crystal River began to wane between AD 500 to 600, which corresponds with possible climatic events and a shift towards the occupation and development of the Roberts Island built environment. However, it should be noted that not all activity at Crystal River ceased. As indicated on these slides, mounds A and J were completed during these phases. It has been postulated that a sort of caretaker household was possibly present at Crystal River during these final stage phases. Indications of human interaction with Roberts Island environment began as activity slid at Crystal River between 500 to 600, evidenced by a small midden area in the center of the island. However, it did not take long for growth to occur. Towards the end of the middle woodland period and the beginning of the late woodland period, Roberts Island became the center of focus for construction. As illustrated on the slide, 3 platform mounds were constructed during this time, and the midden expanded to encompass a much larger portion. With this shift to a new location, would other changes occur as well? Would my research shed any new light on continuity of construction traditions and village life? Well, before I can get into answering any of those questions, I want to tell you a little bit more about the methods I used during this study. Pictured here is an example of shell midden material. Now imagine trying to find very small otoliths amongst a bunch of really old shell and shell fragments. Let's just say the illustration on the right accurately depicts how I felt numerous times during my study. Once I located the otoliths, it was time to prepare them for analysis. This meant many hours, days, and weeks of washing and then prepping them to be thin sectioned so I could examine whether the interior of the otolith was preserved well enough to be able to gather data from. Depicted on this slide in the upper right corner is a spotted sea trout otolith that eventually had to be excluded from the study. As you can see, when you compare the two, there's almost no way for me to determine where the growth bands are present. However, as you can see here, I did end up finding plenty of otoliths that I was able to perform analysis on. These over here are examples of spotted sea trout otoliths, and these over here are red drum. The difference for the white background for this one and then the dark black background just kind of has to do with preservation of the otolith and readability. So it's kind of, hit or miss which one an otolith would be. In total, I analyzed 112 otoliths during this study. While I was unable to reach my initial unrealistic, possibly naive graduate student goal of 30 otoliths from each phase and each site's context, I still feel the study has a robust sample size and provides meaningful data and information. I know you're all thinking math slides, great. However, I am just showing you an example of the process for the species. Running statistical analyses was a very important part of this research since I needed to be sure the pre-contact and modern populations were not vastly different. Since the modern specimens were serving as my means for determining the season of capture for the archaeological otoliths, I used independent samples t-tests to compare the various populations. First, I compared the archaeological assemblages. I found that there was a statistically significant difference between the otoliths with the first annulus present from Crystal River and Roberts Island. While this is not the result I was hoping for, since I wanted to combine the archaeological samples to compare with the modern assemblages to increase my sample size, I found studies that suggested harvesting pressure or environmental events could impact growth rates of these fish, especially fishes of this given age group. So as you can see over here, my hypothesis was rejected due to the difference in the populations. Next, comparisons were made between the combined pre-contact assemblages and the modern assemblages, when statistically significant differences were observed during the prior analysis. I separated them back into their respective site assemblages and compared each to the modern assemblage. An example of this is provided at the bottom of the table. It became evident that the growth zone between the first and second annulus for both red drum and spotted sea trout were statistically different from the modern assemblage. In both cases, growth was less. This was not the end of the world or the end of the line for seasonal determination for these otoliths. Instead, it just had to be taken into consideration during the last step of analysis. However, first I needed to see if the growth rates of the marginal edge for red drum and spotted sea trout otoliths increased throughout the year. So as you can see, we have an increase through the months in our red drum species. We also see the increase with the spotted sea trout. And these are the different ages of fish that were used in the study and analyzed. Some of you might be wondering, well, what's this over here? Because it's not increasing or decreasing. This is actually exactly what is anticipated. During the summer months, warmer months, we see rapid growth. So you're going to see the increase. And then once the quote unquote Florida cooler months hit, you start to see the growth slow and new annuli form. And so that is what is being depicted here. Next, I needed to see if there were patterns within the months. I used histograms, which are depicted here, to group months together and form the seasonal patterns of growth. As you can see, for this annulus, I had to create 5 monthly groupings based on the data. The goal was for the shape of the distribution to gradually move to the right, except you can see that the first grouping, the months associated, again, with the cooler months, the growth is split. That is because the new annuli are forming, which is expected since this is the slow growth period. Spotted sea trout with 2 annuli present ended up needing to be broken down into 6 seasonal categories. But the continual growth through the months is clear. Now for the last step in the process. The time finally came for me to determine which seasonal grouping each archaeological otolith would align with. I used these bar graphs, which provide the mean width of each seasonal grouping and the width of each archaeological otolith. I also used the mean annuli width to assist with the process, especially in cases when there were statistically significant differences between the archaeological and modern assemblages. Finally, I arrived at the results. Using all of the aforementioned findings, this graph presents a clear picture of the seasons red drum were captured at Crystal River and Roberts Island. The results offer interesting insight into the larger discussion of activities that were taking place at these sites. First, Placan and Thompson believe the site was only seasonally occupied during the beginning of Crystal River's occupation, an assertion that is supported by their oyster study. The evidence from this study further supports that claim, with all 3 red drum otoliths recovered from the earliest midden contexts, indicating that indicated capture during the cooler months of the year. Second, the quantity of otoliths and seasonal designations, these otoliths were covered from Mound 3 Mound phase 3 and midden phase 2 contexts at Crystal River also support Placan and Thompson's belief that during this occupation period, the site was inhabited throughout the year and activity at the site was at its pinnacle. Third, the results also support Placan and Thompson's assertion that activities declined at Crystal River during Mound phase 4 and midden phase 3, which are evidenced by the decrease in quantity of otoliths. They suggest from their extensive research that the site was still occupied throughout the year, but possibly only by residents of higher status individuals who remained at Crystal River to take care of the mounds and perform rituals. Results from my red drum study supports their notion that the site was still occupied during cool and warm seasons. Unfortunately, no red drum otoliths were analyzed from this study from Mound Phase 5, Midden Phase 4 context at Crystal River. The red drum otoliths from Roberts Island provide additional insight into activity at this site. As noted earlier, activity at Roberts Island increased during Mound Phase 4 and Midden Phase 3. Placan and Thompson observed in their shovel test an abundance of artifacts recovered in the lower levels and interpret from this evidence that occupation and construction began at the site during these intervals, albeit on a small scale. While the Roberts Island red drum assemblage is very small, it only consists of 3 otoliths, it does suggest the site was at least occupied during cool and warm seasons. The final phase of construction and habitation of Roberts Island occurs during Mound Phase 5 and Midden Phase 4. Placan and Thompson believe that during this period, both mounds were constructed during cooler months. And Roberts Island became the new civic ceremonial center in the area. The complete red drum assemblage for this phase remains relatively small. I only have 11 otoliths, and suggests an increase in activity when compared to the preceding phases assemblages. The red drum seasonality results from mound context suggest agreement for Mound A with cooler month signatures. However, my data disagree with their assessment of Mound B, with both late warm and early cool seasonal designations being present. Combining all spotted sea trout results an informative picture of the seasons these fishes were captured and subsequently discarded at Crystal River and Roberts Island appears. The results reveal intriguing information about when activities were and were not occurring at these 2 important middle and late woodland civil ceremonial centers. Following chronology of the sites, I found additional evidence to support Placan and Thompson's belief that during Midden Phase 1 at Crystal River, the site was initially seasonally visited in cooler months only, and then transitioned to year-round occupation as the early village emerged towards the end of this phase. All 3 spotted sea trout that were analyzed from these contexts have marginal widths consistent with capture during the cooler season, also known as January and February for the otoliths with that annuli, and provides an additional line of evidence to support Placan and Thompson's interpretation of the activity of hunter-gatherer activity at Crystal River during Mound Phase 2 and Midden Phase 1. During Midden Phase 2 at Crystal River, the sub-assemblage of spotted sea trout otoliths offers further evidence to support year-round occupation of the site, since every seasonal designation is present. There is also evidence from these results that illustrates a marked increase in the quantity of this phase's otolith sub-assemblage. This observation aligns with Placan and Thompson's assertion based on site construction activity, midden accumulation rates, and material culture. This evidence from Crystal River indicates Crystal River was no longer a vacant ceremonial center and early village, but had transformed into a sedentary village and a regional civic ceremonial center. The sole otolith from Crystal River mound context lightly dates to this phase of occupation. The otolith was found in a core sample that was taken from Mound A. Placan and Thompson are cautious regarding their interpretation of this genuinely monumental piece of architecture due to its complicated stratigraphy and potential to have repurposed midden material included within its construction. Likewise, I am cautious to make a grandiose assertion that this single otolith provides evidence that the second construction episode of Mound A occurred during the cooler season, as indicated by my seasonality results. It is, however, extremely tempting to infer winter construction since Thompson and Placan's oyster study provides ample evidence to support their belief that construction of the Other mounds at Crystal River occurred during cooler months. Also noteworthy is the concentration of otoliths that were found in Trench 4 located close to Mound A and the lagoon area. Given the abundance of otoliths and the seasonal signatures indicating year-round and proximity to the indicating year-round occupation, I propose that this area may likely have served as a fish processing area during midden phase 2 at Crystal River. After the height in village and regional activity, Lacan and Thompson report a sharp decline during the Mound phase 4 and midden phase 3 period at Crystal River. Interestingly, a drop off in quantity of otoliths occurs at this time as well, thus providing an additional line of evidence to support waning activity. Despite the decline, the spotted sea trout results from this phase also supports their evidence for continued year-round occupation of the site. The final documented occupation at Crystal River, Mound phase 5 and midden phase 4, is the area north of Mound A. Lacan and Thompson observed another decrease in midden accumulation at this time. They interpreted from the evidence gathered at the site that the area was possibly occupied by a caretaker population or family group. The spotted sea trout results from this period indicate year-round occupation and supports their claim that site activity had decreased, which is evidenced by a decrease in the number of otoliths as well. The spotted sea trout assemblage from Roberts Island sheds new light on activities that took place there. During Mound phase 4 and midden phase 3, Lacan and Thompson found evidence that this area began to be inhabited. They postulate a few reasons for the possible move to this location, including environmental changes that could have impacted the availability of fish species used in the study. The limited seasonality results, only 2 otoliths were analyzed from the midden area, suggest use during the cool and late cool seasons. The next phase of occupation in Roberts Island, Mound phase 5 and midden phase 3, suggests a proverbial boom of construction and site activity. Lacan and Thompson point out the oddity of Roberts Island's fluorescence given the absence of mound building taking place elsewhere in the region. Nevertheless, mounds A, B, and C were constructed during this phase, and Lacan and Thompson interpret from their research that mounds A and B were constructed in single episodes. These constructions events were also constructed during the cooler months. The spotted sea trout seasonality results provide additional evidence to support this claim. All spotted sea trout otoliths recovered from mound contexts at Roberts Island indicated a capture during cooler seasons. There is additional evidence, albeit small, when compared to the height of activity at Crystal River, which suggests year-round occupation from midden contexts at Roberts Island. I discussed the seasonality results of the red drum and spotted sea trout assemblages from Crystal River and Roberts Island separately. While these discussions painted 2 pictures of activities at these sites, combining the results offers better evidence to address the main research questions of my study. This slide demonstrates again the amount of activity that occurred at Crystal River during Mound phase 3 and midden phase 2, when the majority of the construction projects were taking place. However, by combining the midden phase 4 and Mound phase 5 results from Roberts Island, there is a clear indication of year-round occupation at the site and the second highest count of otoliths for a phase. This slide presents the combined seasonality results in a slightly different light through percentages of each seasonal designation for the various phases and contexts. This portrayal of the results indicates these species were caught more in the cooler seasons than the warmer seasons. This observation is interesting since both species can be caught year-round in estuarine waters. Only because the red drum assemblage consisted of fishes 0 to 4, as older red drum fish moved to coastal waters during certain times of the year. Aside from these initial observations, I am able to delve in more deeply and address my main research questions. First, were seasonal deposition events involving the construction of monumental architecture taking place at Crystal River and Roberts Island? Second, did feasting act as a mechanism to organize the labor needed to construct monumental architecture? The combined results from this study provide further evidence that seasonal deposition events were taking place at these sites, and a link between these activities and monumental construction is clearer. The results from the Crystal River Phase 1 all have signatures for capture during cooler months of the year. During this time, Crystal River was transitioning to an early village steeped in traditions from the preceding period when the site was used as a burial ground. The evidence suggests people gathered at the site, feasted on oysters, fishes, and high-status mammals, worked on construction projects in the main burial complex and Mound G, and began to show symbolic connections to the local area by selecting marine shell pendants as common burial goods. Applying Dietler and Urbich's collective work events model to this time, I postulate that the smaller scale projects were likely closer to the work feast end of the continuum. My assertion is based on the evidence from Crystal River that suggests two communities were possibly coming together, thus requiring a more of a reciprocal cooperation in site activities to enhance connection between groups and to the land. The scale of these early construction projects was smaller than those that occurred in the next phase, so a large labor force was not needed. However, catchment practices, even in this phase, would have required a good amount of people to catch fish in weirs, nets, or traps and collect oysters for communal consumption. It is quite possible that these subsistence practices helped to bring these groups together and solidify a bond. There is one noteworthy line of evidence that provides additional support for this interpretation. In the interval preceding midden Phase 1, when Crystal River is believed to have been a vacant ceremonial center for mortuary practices, many of the individuals who were interred in the burial mound were buried with plummets made from a variety of materials, some local and some exotic. Plummets were attached to the bottom of nets that were used to capture large quantities of fish. Perhaps in a few cases, the plummets associated with these early burials represent a link to a fishing ritual that included catching fishes for the feasting and construction events that were held during the cooler months of the year. However, there is plenty of evidence to support that the majority of the plummets associated with burials were personal adornment items that were traded between communities. Based on all this evidence, I put forward the idea that an important tradition was established early on at Crystal River that would continue through occupation at Roberts Island. During cooler months of the year, groups near and far would gather at Crystal River, work together to catch and collect resources for a feast, engage in construction projects that included using the feasting remains as building materials, and perform mortuary rituals to honor those that had passed. The evidence provided from the Otoliths seasonality results to support the continuance of this tradition in Mound Phase 3 and midden Phase 2 at Crystal River is somewhat less direct. Unfortunately, only one spotted sea trout was available for this study from Mound context at Crystal River. The results did offer tenuous support for the construction of Mound A in cooler months. However, given that there is only one otolith, and Flacon and Thompson cautioned the possible use of repurposed midden material in Mound A's construction bill, I consider this evidence inconclusive. Still, there is alternative evidence that can be used to support my assertion that this feasting and construction tradition in cooler months continued. First, Thompson and colleagues' oyster study provided ample evidence that the oysters found in the construction of the mounds at Crystal River were collected during cooler seasons. This evidence shows a direct connection. Second, the human interments during this time are reported to have an abundance of grave goods made of shell, particularly plummets. As I noted above, these may indicate the importance of mass capture fishing techniques, although there are alternative interpretations of these plummets. In the absence of a more robust assemblage of otoliths from mound context, I turn attention to otoliths from midden context to provide an indirect line of evidence for support. Trench 4 at Crystal River contained an abundance of otoliths when compared to other investigated areas of the site. Nearly 55% of all otoliths were recovered from this context. I believe, as noted earlier, that Trench 4's proximity to the lagoon and Crystal River and the abundance of otoliths recovered from this area were likely used, this area was likely used to process fish during this period. The seasonality results from this trench show that both red drum and spotted sea trout were captured and their remains were deposited throughout the year. While this information is useful, a refined examination of the results by levels and features provides an intriguing supposition. In level 8 of units 9 and 10 of Trench 4, a number of loci were identified. These loci, locus G, locus E, and locus H, all contain spotted sea trout caught during the cooler months of the year. While this could simply be evidence of a mundane fish processing event, it could also be the signature of a feasting event. Regardless, really, of when this event took place and if the fishes were part of an everyday meal or a communal consumption event, this context illustrates that mass capture events were taking place at Crystal River during cooler months and this phase of occupation. Therefore, based on the direct and indirect lines of evidence discussed here, I argue that this evidence to support my notion for the continuation of feasting and construction in cooler months was taking place during this time. Also, given the large-scale construction projects that took place during Mound Phase 3 and Midden Phase 2, the likelihood of purely work exchange events is less likely. I propose, based on the aforementioned evidence, that during this phase of the villagers of Crystal River, during this phase, the villagers of Crystal River held work feasts to recruit the labor needed to construct mounds H and K entirely in the initial stages of mounds A and J. They would have relied on the established tradition of inviting connected communities to come during the cooler months of the year and aid them with these monumental projects. And in return, the Crystal River villagers would have spoiled their guests with copious amounts of oysters, fishes, and other resources. Attention now shifts downriver to the next major pre-contact construction events at Roberts Island. Was the tradition of feasting and construction in cooler months continued there? The combined seasonality results from Mound A suggest a continuation of some traditions. This assertion is based on the evidence that all fishes were captured during cooler months of the year, thus aligning with the oyster study. Another line of intriguing evidence is the other oyster study that indicated oysters in mound context were harvested from higher saline oyster beds as opposed to the oysters deposited in midden context that came from lower saline environments. The potential of restricted access to oyster beds could suggest the villagers of Roberts Island were using these beds as a way to create surplus and prepare for large feasting events. It is also possible these higher saline oyster beds had ritual power associated with them, and their shells gave the mounds additional significance. Unfortunately, it is difficult to say whether plummets were still included in burials or traded with other communities from people associated with this site, because a burial area has now been found at Roberts Island. However, I believe the other aforementioned evidence provides suitable support that some form of collective work events were taking place at Roberts Island as well. I am hesitant to say exactly where on the work exchange work feast continuum these events would fall, but there is sufficient evidence at a minimum to support that members of the Roberts Island village could have hosted large-scale feasting events, and they definitely needed a large labor force to accomplish the monumental tasks that they accomplished, their monumental tasks. The results derived from Mound B at Roberts Island, however, do not support a continuance of the mound building during winter month tradition. The spotted sea trout recovered from the mound were all captured during cooler months, but the red drum assemblage is split between signatures from warm and cooler months. 2 of the red drum otoliths were captured during the late warm season, while the other 3 in this subassemblage were captured in the early cool season. Perhaps these 2 red drum fishes had slower growth rates than usual and were caught in cooler months, like the rest of the fishes deposited in this context. There is also the possibility that some repurposed midden material was used in the construction of Mound B. Another plausible explanation is that other rituals were performed on Mound B during warmer times of the year after construction was complete and the otoliths migrated down into the original construction material. Despite the evidence from Roberts Island Mound B, I believe a strong argument has been presented that connects feasting and construction events in cooler months together at these sites. And I want to give a special thanks to Central Gulf Coast Archaeological Society and AWARE, and to all of you for coming and joining virtually tonight, as well as all these other people that assisted with my research. And happy holidays, everybody.
Well, very exciting results, Liz. Thank you.
Thank you. I will say that boiling a 250-page thesis down into a 45-minute presentation might have been as difficult as actually writing it. Especially with all of the statistics that I ran. I definitely didn't want to sit here and have slide after slide after slide of statistical results and analyses. But if anyone has any questions, I am happy to answer them.
Well, we thank you for that. So yeah, if anyone had any questions, go ahead and type them in the chat. There are some other things going on in the chat, Liz, if you wanted to.
I have no idea even how to see that.
Okay, let me read you what Sheila Stewart said. Your study certainly adds to our understanding of development in the Crystal River cultural area. It was interesting to hear your analysis based on otoliths, which seems so specific to me, but which has wider implications, as you argued well. Thank you for your good work, Liz.
Thank you, Sheila.
Great talk.
Wow.
Well, I'll start off with a question while people are thinking. So I know the focus was of season of collection, but I think in order to do that, you are kind of paralleling, you'll know the age of the fish, right? I was wondering if you saw any shifts in the age of fishes being targeted, or if it remains kind of stable. And side question, what was your oldest fish?
So, well, be honest, well, first to address your first question. So they were pretty stable actually between the assemblages. I didn't really find any that are younger than like the young of year. So ones that hadn't formed an annulus yet, which I thought was kind of interesting and maybe suggests that, certain nets and net sizes were being used since that population was just completely absent from the assemblage. The oldest red drum fish that I was able to age was 4 years old. For some reason, red drum seemed to not preserve as well as the spotted sea trout. Spotted sea trout, the oldest fish that I documented was 7 years old. However, none of those compare. I also tried to do the hardhead catfish species, since it's one that is so frequently found in archaeological contexts here along the Gulf Coast. Started doing the math after a ways into it, after Heather Draskovich and I went out and caught a bunch of modern hardhead catfish to try and get a representative sample. And as I was cutting into the archaeological ones, I realized that I found an archaeological otolith that was 21 years old for the catfish population. And so I would have had to span, I started doing the math and yeah, it was going to be, I needed 30 samples for every month of the year for catfish ages like 0 all the way up to 21. And I was like, yeah, I'm gonna rethink this one and let's just go with 2 species as opposed to 3.
So there is another question in the chat by Dennis Pearson. Did they eat oysters more during the winter for safety reasons? Because restaurants in Florida only sell raw oysters during cooler months to minimize foodborne illness.
That is a fantastic question, and it is a plausible explanation for oyster consumption and why we are finding it in winter months in abundance from the mound context, but we also find it actually in the all seasons of the year when you look into the everyday midden material. So I'm not sure if maybe the foodborne illness wasn't an issue for them, or if I know that I'm a big oyster fan, and as long as I'll eat them any time of the year. Let's put it that way.
Yeah, it also highlights the importance of your study too, because when you're only looking at one species and seeing oysters, if they were harvested for safety purposes during the winter, that skews interpretations. So when you're bringing in multiple species like you have here, it either supports or doesn't. That mound building was a very specific time of year. But that pattern does seem to hold true, which is pretty interesting.
It really, yeah. I was, especially using the 2 different species, I thought that I could really get some varying results. I did with Mound B at Roberts Island. But that there are different reasons that could have been the case. And Mound A was really the one that was, more of the ritual, and then the other was more on the side of possibly residential. But I agree that, I kind of like having the multiple lines of evidence in different fish species to draw these conclusions.
Awesome.
And also I think one of the first things that I thought when I started really delving into this research is, I love oysters and everything, but I don't think that like a feasting event where all you do is offer your guests oysters, that might not keep people coming back for more every time. I feel like you kind of need to diversify things and have a variety of foods. And so having evidence for, now we have 2 fish species as well as the oyster, I think really kind of helps to aid in that argument.
Absolutely. Oh, I don't see another question. I'll ask another one, and
Okay.
hopefully I'm not cutting anyone. Oh, never mind. So I think this is Dennis Pearson again. Was the sea level lower 1,000 years ago? The areas that are indicated as being marsh now might have been drier in the past.
So I did one of the things that I mentioned about one of the possible reasons for that, the difference between the modern population of both spotted sea trout and red drum during that growth period of the first annulus being laid, and then the second one was the potential for an environmental event, environmental change. And there is evidence. My cohort member, colleague, Kendall Jackson, conducted a study from Crystal River, and his evidence actually suggests that there was a climatic event that occurred between that 580, 500, 600 timeframe, which potentially sea levels were lowered. And so, migration towards Roberts Island from Crystal River would, make sense and, give them closer access to the resources, because that would have caused a drop in sea level.
Great. James Pepe asked, are otoliths only found in saltwater or estuarine fish species?
Nope, they are found in all. The size of the otolith really varies though. The murkier the water, the larger the otolith is going to be, because fish out in the nice clear blue sea, like the one that's I'm using as my backdrop, fish can see really well, so they don't have to rely on their hearing as much. But when it comes to fish that frequent estuaries, brackish water, freshwater, their otoliths are going to be much larger, because they rely more on hearing. And hi, Jim.
That's cool. So my other question was related to how you mentioned there was a difference between modern and ancient otoliths, and how it is most likely related to environmental change or potentially pressures. Did you find that the FWC was interested in understanding why, or interested in archaeological data sets at all? Or because I get kind of mixed reviews, like some biologists are like, oh yeah, this is very beneficial. And some are like, I don't know how to combine archaeology and modern data.
Yeah, no, I have, I got positive feedback, interaction. I actually still sometimes get emails from people over at FWC, asking me about different species. What was really interesting is there was this one otolith that I think was a catfish otolith, and it looked like, here, wait, let me flip back in time. Can y'all still see this?
Yeah.
Okay. So on the interior of an otolith, so I mean, even though you can definitely see how translucent it is right here, but this one otolith looked like all of this area had turned to glass. And I asked them, I was like, what in the world would cause this? Because the people that I was working with in the lab, they literally analyzed the tens of thousands of otoliths every year. And they were really kind of surprised to see that archaeologically. I think some of the things that they had suggested or thought that what would have caused that was, exposure to some sort of chemical or something like that. And so seeing it archaeologically really made them scratch their head, and they actually were, and I ended up not being able to use the specimen because A, it was catfish, and B, because I wasn't able to use the growth rings. And so I left them actually one of the thin sections I took because they wanted to investigate it further. But like I said, I've also been contacted since finishing my research, and have directed them towards other archaeologists for certain species that they're looking for. And then also, people that work in different areas than I do here in Florida.
Awesome. Thanks for sharing. Hopefully they figure out what that was.
Right. I know. I still think about it. I still wonder, what would have caused that? Part of me wondered if maybe it got bumped on the head or something, and it had a developmental thing. But the problem is that even with the way that they churn over their fish and pull the otoliths out and, cut them up and all that kind of stuff, it happens way after the fish has already been disposed of. So, there's no way for them to connect it back. But one of my thoughts was, I wonder if, little fishy bumped into something and had, injured that portion of its skull or something like that. And, but I'm just taking stabs in the dark. No clue.
Wow, that'd be cool. Well, I think those are all the questions. So I just want to say thanks again and
Absolutely.
happy holidays to everyone. Thanks for coming. Appreciate it, Liz.
Yeah. Thank you, everyone, and happy holidays.